Hello everyone, welcome back to the channel. Today I have a very interesting exponential equation for you. And if you have never seen the Lambert W function before, this problem is going to be a lot of fun. So before we start, pause the video for a moment and see if you can solve this on your own. The equation is 3 to the power y plus y equals 7. Our goal is to find the value of y. Now at first glance, this doesn't look like a typical exponential equation. We have the variable y both inside an exponential term and outside the exponential term. That usually means our standard algebra tricks are not going to work. So let's begin. The first thing I want to do is move the y to the other side. That gives us 3 to the power I equals 7 minus y. And just for convenience, let's write it as 7 minus y equals 3 to the power y. Now watch carefully. I'm going to divide both sides by 3 to the power y. So we get, open parenthesis, 7 minus y close parenthesis divided by 3 to the power y equals 1. Using exponent rules, we can rewrite this as, open parenthesis, 7 minus y, close parenthesis, times 3 to the power minus y equals 1. And now, I'll write the first factor as, open parenthesis, minus y plus 7, close parenthesis, times 3 to the power minus y equals 1. Nothing has changed. I simply rearrange the terms. Now here's where things start getting interesting. My goal is to transform this equation into a form that looks like a times e to the power a. Because whenever we see that pattern, we can use the Lambert W function. So the question becomes, how do we create the same expression both outside the exponential and inside the exponential? Well, watch this. Let's multiply both sides by 3 to the power 7. Doing that gives, open parenthesis, minus y plus 7, close parenthesis times 3 to the power minus y, times 3 to the power 7 equals 3 to the power 7. Since the bases are the same, we add the exponents. So we obtain, open parenthesis, minus y plus 7, close parenthesis, times 3 to the power, open parenthesis, minus y plus 7, close parenthesis, equals 2,187. And now we have something very important. Look closely. We have minus y plus 7 outside the power, and we also have minus y plus 7 inside the power. That is exactly the structure we were hoping to create. The only issue is that the base is 3. For Lambert W, we want a base of e, but that's easy to fix. Remember that 3 can be written as e to the power natural logarithm of 3. So let's replace every 3 with e to the power natural logarithm of 3. The equation becomes, open parenthesis, minus y plus 7, close parenthesis, times open parenthesis, e to the power natural logarithm of 3, close parenthesis, raised to the power, open parenthesis, minus y plus 7, close parenthesis, equals 2,187. Now apply the power rule. Multiply the exponents together. That gives, open parenthesis, minus y plus 7, close parenthesis times, e to the power, open parenthesis, natural logarithm of 3, multiply by open parenthesis, minus y plus 7, close parenthesis, equals 2,187. We're getting very close now. The only thing stopping us from using Lambert W is that extra natural logarithm of 3 sitting inside the exponent. So let's multiply both sides of the equation by natural logarithm of 3. Doing that gives natural logarithm of 3 times open parenthesis minus y plus 7, close parenthesis times e to the power, open parenthesis, natural logarithm of 3, multiplied by open parenthesis, minus y plus 7, close parenthesis, equals 2,187 times natural logarithm of 3. Now let's make a substitution. Let a be equal to natural logarithm of 3 times open parenthesis minus y plus 7 close parenthesis. Then our equation becomes a times e to the power a equals 2,187 times natural logarithm of 3. And there it is, that famous Lambert W form. Whenever we have a times e to the power a, we can immediately apply the Lambert W function. So we get a equals Lambert W of open parenthesis 2,187 times natural logarithm of 3 close parenthesis. Now, let's substitute. Back. Natural logarithm of 3 times open parenthesis minus y plus 7 close parenthesis equals Lambert W of open parenthesis 2,187 times natural logarithm of 3 close parenthesis. Next, divide both sides by natural logarithm of 3. So we have minus y plus 7 equals Lambert W of open parenthesis 2,187 times natural logarithm of 3 close parenthesis divided by natural logarithm of 3. And now for the final step. Solve for y. Therefore, equals 7 minus Lambert W of open parenthesis 2,187 times natural logarithm of 3 close parenthesis, all divided by natural logarithm of 3. And that is the exact answer. But let's also find a decimal approximation. Using a calculator or mathematical software, we find that Lambert W of open parenthesis 2,187 times natural logarithm of 3 close parenthesis is approximately 5.9367. Substituting that value gives y approximately equals 1.597. So our final answer is y approximately equals 1.597. Pretty amazing, right?